Alright, so I'm ready to do another example of area between curves, and in this case I have a slightly more difficult problem where I'm finding the area of the region bounded by y equals sine of x, y equals cosine of x, x equals 0, and x equals pi over 2. So in this case, what I'm going to do is I'm going to start off, again, try to graph these because that's really important when you're trying to find area between two curves. What I'm going to do is I'm going to graph the easy ones first, these vertical lines, x equals 0 and x equals pi over 2. X equals 0, hopefully you guys know, is the y-axis. X equals pi over 2 is right here. Now I'm going to draw this as a dotted line, so hopefully you guys remember this is, again, a boundary. It's just kind of cutting off my x's so I know where to be in between. Now I'm going to go ahead and start graphing the other ones, which are y equals cosine and y equals sine. I'll do sine first. I'll do it in blue. So hopefully you guys remember sine starts at the origin, 0, 0. It comes up to 1 at pi over 2, comes back down at 0 at pi, goes to -1 at 3 pi over 2, and at 2 pi, it's back to 0. Remember, it fluctuates. It has that nice, beautiful wave pattern that everybody loves. There's the that's sine. All right, so there's y equals sine of x. All right, now I'm going to go ahead and in red do cosine. Hopefully you guys remember cosine is just shifted over a little bit. It starts off at 1, comes down to 0 at pi over 2, -1 at pi, comes back up. So this looks more like a roller coaster instead of a wave. So it starts at the top, comes down, 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 then goes back up, 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 and then curves off at the end. So there's cosine in red, sine in blue. So that's important stuff to have done. Now again, we're looking for the region between x equals 0 and x equals pi over 2. So I'm going to go ahead and point out to you, in this case, this is a slightly more difficult problem because when I look at the graph, I find out that there's actually two areas. That there's this one here, and I'm going to color it in green, where it's the red on top, cosine on top, sine on the bottom, and there's also, and I'm going to color it in green, or excuse me, not in green, but in pink, this area right here, where sine is on top and cosine is on the bottom. Now, hopefully you guys pick up on the fact that this point right here where they intersect is actually pi over 4, and the square root of 2 over 2, okay? Hopefully you guys picked up on that. Just remembering your unit circle, that's where they cross. So, here's what I'm going to do. I'm going to actually have to split this up and do two different definite integrals, trying to, again, separate the two separate areas. And what I'm going to do in the end is I'm going to add them up. Unfortunately, if you did a definite integral of just this whole thing, you would end up with 0. And I don't want that. I want the actual area. So again, I'm going to split it up into two different pieces. I'll do the green one first. Notice it's going to start at 0 and go to pi over 4 for the x values. And I'm going to do, again, the red one is on top. That's cosine. And the blue one is on bottom. That's sine. So I'm going to do cosine of x first minus sine of x. And I'm not going to forget my dx. Now I'm going to go ahead and start working on the integration. Hopefully you guys remember the integral of cosine gives me sine, and then I'm going to do minus the integral of sine, which is going to give me negative cosine, and I'm going to evaluate that between 0 and pi over 4. Double negatives is going to make that positive, so sine of x plus cosine of x over that evaluation interval. Now I'm going to go ahead and just plug it in. So I'm going to do sine of pi over 4 plus cosine of pi over 4 minus sine of 0 plus, I'm writing sine again, cosine of 0. Now, I put a theta. One of the things I want to make sure I point out to you, hopefully you guys remember, sine of 0 is 0, but cosine of 0 is 1, okay? Sine of pi over 4, again, I went ahead and was talking about it over here. It's the square root of 2 over 2, and cosine is 2, okay? So right now I'm at the square root of 2 over 2 plus the square root of 2 over 2 minus 0 plus 1, which is just going to be 1. So I'm going to go ahead and write this down. If you have the square root of 2 over 2 plus the square root of 2 over 2, you're just going to get the square root of 2 because it's, if you hopefully remember your stuff, it's 2 square roots of 2 over 2, and the 2's cancel out. You guys see where I'm going. So I've got the square root of 2, and then it's minus 1. So right now that is the area, the exact area of my curve in this case. So it's the square root of 2 minus 1. It's approximately 0.414. I'm not going to worry about that so much. I'm going to leave it alone for right now and just leave it as the exact area. Again, writing this down, it's the square root of 2 minus 1. Now, as I mentioned before, these are actually going to be the same size. There is a lot of symmetry in this. So I know that the other one's going to be exactly the same. I'm just going to go ahead and prove my point, though, just so you guys see it. So I get across that one important fact, which is, remember, the function on top needs to go first. So I'm going to go ahead and do the other one in pink. So we're going to do, in this case, the integral from pi over 4 to pi over 2. And again, sine is the one on top this time, so it's going to go first. And we're going to subtract cosine and just work out the problem in the exact same way. So here I go. Sine of x, when I integrate, is going to become negative cosine. And this is going to be minus sine of x here. And I'm going to evaluate between pi over 4 and pi over 2. So let me go ahead and try to start plugging this stuff in. So we're going to do, and I'll actually also factor out that negative. So it's cosine of x plus sine of x. That'll make my life a little bit easier. Pi over 4 to pi over 2. All right, so I'm going to plug in the pi over 2. So I'm going to do negative cosine of pi over 2 plus sine of pi over 2. And then I'm going to subtract the negative of that thing. So it's going to end up being adding cosine of pi over 4 plus sine of pi over 4. All right, we just did this stuff. So cosine and sine of pi over 4 are going to be the square root of 2 over 2, which is going to end up giving me just the square root of 2 as the answer. And I'm going to add that to, in this case, the negative cosine of pi over 2, which, again, cosine in this case is going to be 0. In this case, sine of pi over 2 is 1. So we're going to add negative 1 to it. So, like I said, we get the exact same answer. It's no different. It's the only thing that I would expect anyone would write any differently. They would probably write negative 1 plus the square root of 2. Again, it's the same answer. It's not such a big deal that they're switched. So now that I have both of those answers, and I know for certain that they're exactly the same, well, all I got to do is just add them up. Okay? That's all I'm going to do is add those two things together and get my final answer. So, square root of 2 minus 1 plus the square root of 2 minus 1, or you could even, multiply it by 2 since it's doubling. So you're going to get 2 square roots of 2 minus 2, which, again, I'm going to just double check in my calculator to get a good approximation of it. It's 0.828 and some change. I'd honestly prefer this answer because it's more exact. That's a rounded off answer, but that's the area between those two curves. Notice that's the green and the pink area combined. Hopefully that helps you guys understand this a little bit better. Remember, first most important thing, graph it.